In this video, we're going to be continuing our look at simulation modeling. In the last video, we took a look at how to simulate data that came from a population with a discrete distribution, a population with a uniform distribution, and a population with a normal distribution. In this video, we're going to take a look at how to put those ideas together so that we can create a data set that will help inform our decisions in a larger real-world problem. Now, before this video, you should have completed your reading from Chapter 5 on pages 195 to 219 of your textbook. And we're going to follow a similar idea to what they did in the examples they discussed on those pages. We're going to take a look at one of the case modules in your textbook, and the module we're going to take a look at is the Gentle Lentil Case Module on pages 219 to 222 of your textbook. So if you haven't already done so, you should pause this video for now. Take a look at the case module in your book, read through it carefully, jot down the important information, as well as any questions you might have that seem interesting to you, things you think we could solve through our data simulation. Once you've read through the case module and jotted down the features that you think are important, you want to continue with this video, and we'll take a look at working our way through solving Sanjay's problem, or advising Sanjay in his decision through this video. So if you've read through the case module, you know that Sanjay is considering a job offer as a consultant. But what he really wants to do is open a restaurant. And so he'd like to know how profitable that restaurant is going to be. So what we want to do is, rather than have Sanjay have to open the business and see if it's profitable or not, we want to simulate some data so that we can predict whether we expect it to be profitable or not. And so based on what we've read about Sanjay, it seems that his biggest concern is that profitability. In particular, what will his salary be each month? He wanted to ensure that he was earning enough salary to maintain a comfortable lifestyle as well as pay for his school loans. And so we're going to really focus on that salary when we look at the questions that Sanjay wants to answer. Now, it's important that we know the questions we were trying to answer before we start trying to attack the problem, because this is going to inform the data that we need and the data that we need to generate. So as we look at Sanjay's salary, he was concerned with his monthly salary. So one of the questions that we should answer for him is, what is his expected monthly salary? Now, there's a couple of side pieces that go along with that. When we give him his expected monthly salary, we also want to tell him about the shape of the probability distribution of his monthly salary. This will give him a gauge on the reliability of that expectation. We should also inform him of the standard deviation of his monthly salary. This will help him know about variations in that salary from month to month. Now, Sanjay was particularly concerned that his salary be above $5,000 per month. So I would also like to take a look at the probability that his salary will exceed that 5,000 marker. And finally, he was considering a partnership with his aunt. His aunt would fill in his salary in months where his restaurant was not particularly profitable. In particular, if his profit was under $3,500 a month, she was going to kick in money to fill out his salary. So the last thing I want to take a look at is, what is the probability that his salary is going to be less than $3,500 a month? In other words, what's the probability he's going to need his aunt's help? So since all of his questions are about salary, we need to take a look at how we calculate his salary. Now, I'm going to start out by making a simplifying assumption. We're going to assume that his salary comes from the profit of the business. And so we're going to assume that all of the profit that his restaurant makes is going to be his salary. And in that case, his salary is going to equal the restaurant's revenue minus its costs. Now, because Sanjay tells us that he wants to go with a fixed price menu, we know that his revenue is going to be equal to the number of meals he sells times the price for each meal. So I'm going to let capital N represent the number of meals he sells and capital P represent the price per meal. And N times P is going to give us our expected revenue. So the next thing we want to look at are what are his costs. And he has several types of costs. He has a non-labor fixed cost, he has food costs, and he has labor costs. And so we need to be able to calculate each of these, or at least simulate each of these. Now he tells us that the non-labor fixed cost, he expects them to be $3,995. Now he gives us a little more information on this on page 222 in the case module. He gives us a chart that details where these costs come from. These are things like his rent, the leasing costs for his equipment, his utilities, his insurance, those types of things. He expects them to add up to $3,995 per month. So this is going to be an ongoing cost. He also has food costs. He needs to pay for the food that he's going to prepare for his meals. And he's estimated that his food costs will be $11 per meal. So his total food cost should be $11 times the number of meals that he sells, or 11 times N. Lastly, we have his labor costs. Now he gives us some information on page 223 of the case module about the type of staff that he needs. But he tells us that he expects that, based on the information in that table, he expects his labor costs to be between $5,040 a month and $6,860 a month. And in the absence of more information, he tells us to expect that to be uniformly distributed within that range. So for now, I'm just going to refer to my labor costs as L. That's going to be a piece of the data that we simulate. So now that we know how he's going to calculate his revenue and how he's going to calculate his costs, we want to put those ideas together to calculate his salary. So his salary is going to be his revenue, or the number of meals times the price per meal, minus his costs, minus the $11 times the number of meals for the food cost, minus L, the labor costs, and minus the $3,995 non-labor costs. Now we need to know where each of these pieces of information is going to come from. So if we take a look at each of those variables, the N represents the number of meals. And Sanjay told us that based on his research, he expects the number of meals to be normally distributed with a mean of 3,000 and a standard deviation of 1,000. So that's going to be something that we simulate. P is the price per meal. And Sanjay has information in a discrete distribution on what he expects to be able to charge per meal based on the probability that the market is either very healthy or healthy, or not so healthy, or an unhealthy market. And so again, P, that price per meal, is going to be something that we simulate based on that discrete probability distribution. L is our non-labor fixed cost, and he told us to expect that to be uniformly distributed. And so we're going to simulate our non-labor fixed cost as a uniform distribution between $5,040 and $6,860 per month. Now, S is also a random variable. It's a function of N, P, and L. And so we're going to calculate that using our formula that we have there for salary. So what we want to do next, now that we have our formulas and we know what our random variables are going to be, is put our questions that Sanjay is asking in terms of those random variables. So I'm going to restate those questions in a more mathematical format, in something relating to our random variables. So Sanjay is interested in knowing what's the expected value of that variable S. What is the shape of the probability density function of S? What is the standard deviation of S? He also wants to know what's the probability S is greater than or equal to 5,000, and what's the probability S is less than or equal to 3,500. Now these are the same 5 questions we asked before. They're just written in a little bit more of mathematical notation and a mathematical format relating to our random variables. Now we're going to build our simulation in Excel. So what we're going to do now is open Excel, and we're going to create a spreadsheet for our simulation model. So I am going to toggle over to Excel and create a spreadsheet similar to this. So when we're in Excel, I'm going to put a title up here in the corner to help me remember. Gentle Lentil Restaurant. Now I'm going to leave some space at the top because I remember that one of Sanjay's distributions was a discrete distribution, and I like to put my table for my discrete distribution of probabilities at the top of my simulation, so I'm going to leave some blank lines at the top. And then I'm going to create a column that's going to give me my trial number. I want a column for the number of meals. I want a column for the price per meal. I want a column for the labor cost. And then I'm going to put this information all together to give me the salary. That's what I want for now. So I'm going to make some of these bold to make it a little bit easier to see as we go through. All right. Now, before we do a simulation, one of the things we always want to know is how many trials do we want to do? And so we talked in the previous video about how we can calculate the sample size that we need in order to make our decisions. And one part of that process was doing a preliminary sample to get some of the information we needed. So rather than create a simulation with several hundred or several thousand trials at the moment, I'm going to do a small simulation because that's going to inform the size that I need for my overall simulation. So if we remember, our preliminary sample we said should be at least size 30. So I'm going to start out with a few trials. Let's go down. There we go. So I'm going to start out doing 30 trials. This is going to give us our preliminary sample, and then we'll use that information to determine what sample size we really need in order to make an informed decision, and we'll increase the number of trials at that point. So we need to get to our salary, we're going to need to simulate the number of meals, the price per meal, and the labor cost based on the information that Sanjay gave us in the problem statement. Now, if we start out with this number of meals, if we remember, the number of meals was normally distributed with a mean of 3,000 and a standard deviation of 1,000. So as we saw in the last video, we can generate data that obeys the normal distribution using the normal inverse command in Excel. So this is a mathematical command. So in my column for number of meals, I'm going to type equals, and then it was norm inv for norm inverse. And then we need to tell it what we want it to look up, which is our random number, right? We're randomly simulating our data, and we want to randomly simulate a value that has a mean, that comes from a population with a mean of 3,000 and a standard deviation of 1,000. So just like we did for our normal distribution in the last video, we're going to do that here. So we put that in our first row, and then I'm going to go ahead and copy it down for all of my trials. And so each of these numbers comes from a population that's normally distributed with a mean of 3,000 and a standard deviation of 1,000. And so we've randomly simulated the number of meals that he'll sell in a given month. Next, we want to take a look at the price per meal. So if we go back to our PowerPoint for our price per meal, the information they gave us was based on what kind of market Sanjay could expect to have. And he said he felt there was a 25% probability there would be a very healthy market and that he could charge $20 per meal. There was a 35% probability there would be a healthy market and he could charge $18.50 per meal. There was a 30% chance it would be a not so healthy market and he could charge $16.50 per meal. And a 10% chance that it would be an unhealthy market and he could only charge $15 per meal. So for each of those prices, we want to give the range for the random number. So the range for the random number needs to correspond to the probabilities. So since a price of $20 has a 25% probability, I'm going to assign random numbers from 0 to 0.25 to a price of $25. The next 35% of random numbers I want to be assigned to $18.50. So that's going to be from 0.25 up through 0.6. Similarly, the next 30% of numbers should be assigned to $16.50. So from 0.6 to 0.9. And lastly, the last 10% of random numbers should be assigned to $15. So that's from 0.9 to 1. So this is how I'm going to assign my random numbers. So we'll randomly generate a number between 0 and 1, and based on where it falls in these ranges, we'll assign the price per meal we feel Sanjay can charge. Now, I need to give this information to Excel. So this is the information I'm going to include at the top of my chart, or at the top of my spreadsheet in Excel. So I'm going to go back to my Excel spreadsheet. And before I get to the price per meal, up here I want to put this information on the discrete distribution. And so we said we want to give the outcomes, which in this case are prices. And so our price possibilities were $20, $18.50, $16.50, and $15. And the lower bound on probability, remember Excel needs the lower bound on probability. For 20, we were going to start at 0. And that was going to go to 0.25. So our next category starts at 0.25. That needs to be 35% of the values. And so our next category is going to start at 0.6. This needs to be 30% of the values. So our next category starts at 0.9. So we have all of our information that Excel needs here. And then remember, once we've given Excel the information on the outcomes that we want and the probabilities or the random numbers that are going to correspond to those, we use the lookup function. So we come into our price per meal column and we tell Excel we want to look up, and what we want it to do is generate a random number and then look in our chart to find that random number. And where I want it to look is in column E from cell 3 down to cell 6, and I want to match that with an outcome from column D, cell 3, down to cell 6. And you see I use the $ symbol in there because as I copy this formula down, I don't want those references to change. So I want those to be fixed there. So I put in my lookup formula, and you see where that chooses one of my prices. And I'm going to copy that down for all of my trials. All right, and so we see our values filling in. Each time it's generating a random number, it's going to look to our chart and pick the price that goes with that. So we've simulated our number of meals, we've simulated our price per meal. The next thing we need to take a look at simulating is our labor costs. Those obeyed a uniform distribution. So if I go back to our PowerPoint for that, they obeyed a uniform distribution between 5,040 and 6,860. Now remember, our random number generator already obeys a uniform distribution. We just need to shift it so the outcomes are within our range. So if we recall, if we want to shift our random number x to the interval between y sub 1 and y sub 2, we translate it using the equation y equals y sub 2 minus y sub 1 times x plus y sub 1. So for our labor costs, we want these to come out between $5,040 and $6,860. So we're going to fill that ending point $6,860 in for y2. We're going to fill the starting point of 5,040 in for y1, and that goes in for y1 in this portion of the equation as well. So we end up with the equation y equals 1,820x plus 5,040. And so we're going to randomly generate a number between 0 and 1, and then we're going to use this equation to translate it to the interval that we want. So I'm going to go back to Excel, and in our labor cost column, we want to enter this equation. So I'm going to have equals 1,820 times, and we want it times our randomly generated number, right? That's our input value. And then we want to add the 5,040. That's going to take my randomly generated number between 0 and 1, and it's going to move it to the interval where I want. Hit enter, and there's my labor costs. Now remember, Excel does have that shortcut where it will use the rand between function. Will give you a randomly generated integer between the two values that you input there. It's not wrong to use that, but since this was representing a cost, I felt like we could use the decimal points, and so I went ahead and used this particular approach here. And so I'm going to grab that labor cost, and I'm going to drag it down through all of my trials. And so there we see our expected labor costs for each month. Now, lastly, we've generated each of our random variables, our number of meals, our price per meal, and our labor costs. So the last thing we want to do is calculate Sanjay's salary. And we said Sanjay's salary was equal to his revenue minus his costs. And so I'm going to put in here equals, remember his revenue came from his price per meal times the number of meals. So in this case, the number of meals is in B10 times the price per meal is in D10. So there's my revenue minus his costs. His costs were $11 for each meal. So 11 times D10 is the number of meals. So that's minus his food costs, minus his labor cost, which I have stored in F10, and then minus those fixed non-labor costs that he said would always be $3,995. So we have our revenue minus our food costs, minus our labor cost, minus our non-labor fixed cost. And that's going to give us our expected salary for this given month. Now again, I'm going to grab that and I'm going to drag that down through all of my columns, or through all of my trials. And so we've randomly generated his salary. And so this is a simulation of Sanjay's salary. Now we have a trial period of 30 months here. We're going to expand that in a minute, but before we do that, I want to think about the other questions that we asked. We have a lot of questions that we're looking at on his salary. We wanted to know his expected salary, and then we wanted to know the shape of that, and we wanted to know the standard deviation of that. All of that information we can get from this salary column just as it is. The other piece of information that we wanted to have was information on the probability that the salary exceeded $5,000 and information on the probability that the salary would be less than $3,500. And so what I'm going to do is sort of create a flag for that. I'm going to have Excel kind of give me a flag if the salary exceeds $5,000 or if it's below $3,500. So what I'm going to do over here is create a column that says salary is greater than $5,000. And I'm going to widen that up to fit it in there, and then I'll have a column that tells me when his salary is less than $3,500. And what I want Excel to do is simply create a flag. So I'm going to have it put a 0 for yes and a 1 for no. So I'll put a little note up here so that I remember that later on, right? 0 equals yes. 0 equals no. And 1 equals yes. So if the salary is above $5,000, I want Excel to sit a 1 in there. If it's not, I want Excel to put a 0 in there. All right. So the way that I do that is I want to get Excel to take a look at this and decide, is it above 5,000 or is it not above 5,000? And Excel can do that using an if loop. And so in Excel, if you put in if, it will do a test, and then it'll do what you tell it to do in the case that that test is true or that test is false. So if we take a look at my document camera over here, the if loop for Excel, it's a mathematical function, so it starts out with an equal sign, and then we put in if. And then the first thing we want to put in here is the test. If what? If this test is true, then what we put here is our then. After that comma comes our then. If the test is true, what do we want it to do? That's our then. If the test is false, we put something here. This is what we call our else, right? So if the test is true, then we want it to do whatever we've put second. If it's false, else. If it's false, we want it to do what we've put third. So in our case, we want to test and see if the salary is greater than or equal to $5,000. That's going to be our test. Is the salary greater than or equal to $5,000? If it is, then I want to put a 1 in that column. If it's not, I want to put a 0 in that column. And so that's what my if statement is going to look like for if the salary is greater than $5,000. The other one I wanted to check was whether it was less than $3,500. So my other statement is going to be if his salary is less than or equal, or actually I'll make it just less than. I think that's when his aunt kicks in. If his salary is less than $3,500, I want it to put a 1 in my column. And if it's not, I want it to put a 0 in my column. That way I can look down the column and I can add up how many 1s there are, and that will tell me how many times that was a true statement. So if I go back over to my Excel file, I'm going to type that in here. And so it's equals if. Now my salary is stored in H10, so if H10 is greater than or equal to 5,000, I want a 1. Otherwise, I want a 0. And I close off my loop and I hit enter. And so you see a 1 appears because this salary is certainly greater than $5,000. And I'm going to grab that. And I'm going to drag it down the column of all of my trials. And you see I got lots of 1s in there, lots of salaries greater than $5,000, which is a good sign if this is what Sanjay really wants to do. The other thing we want to check is when is it less than $3,500. So I'm going to do equals if, and again my salary is in H10, and we want to know when is it less than $3,500. We want a 1, otherwise we want a 0. So a 0 appears because this is certainly not less than $3,500. And I want to drag that down the column. And lots of zeros in there. See, there's a 1 when he has this small salary, but lots of zeros. Now keep in mind, if you're doing this along with me, because these are randomly generated numbers, your values are not going to be exactly the same as mine, and that's okay. But this is what I have. And so in these 30 trials, on my 30 trials, he only needed his aunt's help once. So again, that's going to inform, does he want this partnership with her or not? So this is the data that we need to inform his decision. Before we can analyze this data, we need to fix our random numbers. For right now, every time I type something new and hit enter, all of my numbers change. And so I don't want to analyze this data with all of the numbers constantly changing. We want to fix those values. But before I do that, I want to make sure I have enough trials. We want to have enough trials to inform our decision properly. And so I'm not going to fix this right now. I'm going to leave this exactly as it is. And I want to encourage you to, at this point, take a moment and save your file. So I'm going to go ahead and save this as my preliminary sample for the gentle lentil problem. Now, keep this in mind because when you're doing homework assignments and things for this class, one of the things I'm going to ask for is a copy of your file with the unfixed values in it so that I can see all the formulas that you have behind the scenes. And so it's really important that we pause and we save our file at this point. So now that we have it saved, what we want to do is determine how large does our sample size really need to be, because chances are 30 is not big enough for us to make a well-informed decision. So we need to know how big of a sample we really need. Now we want to keep in mind we're doing two things here. We're getting information on a probability, right? The probability that the salary is over a certain value or under a certain value. We're also getting information on the mean. We want to find the expected salary, and the expected value, remember, is the mean value. And so we are predicting both a probability or a proportion, and we are predicting a mean. What that means is that we need to use both of our formulas for sample size and choose the bigger value for our sample size. Now, if we take a look first at finding the sample size when we're doing a proportion, if we remember for our last video, we had a formula for finding the sample size when we wanted to estimate a proportion, and a probability is just a proportion. And so the formula, we had one formula that said that our sample size should be equal to 1.96 squared. That was our critical value squared, and we said we'd always use 1.96 for this class. And one of our formulas said we would take P times Q over E squared, where E was our margin of error. It told us how close we wanted to be to the true proportion. And I wrote Q here, but I believe we called this just 1 minus P. P times 1 minus P. Now P is the probability or the proportion we're trying to estimate. Now you can use the sample data that we just collected to estimate P, but there are two different probabilities we're trying to estimate, and so rather than do this formula twice, once for each probability we're trying to estimate and get two different values, I'm going to use that worst case scenario formula that we talked about, where we said if we don't know what we expect P to be, we would just plug in 0.25 for that. And so this is the formula that I'm going to use to determine the sample size I need to estimate my probability. Now, we need to know how close do we want to be. So how close would we like our estimate of this probability to be? If we think about it, Sanjay wants to be pretty sure that he's earning over $5,000 each month. He wants to be well informed as to whether he should take this partnership with his aunt or not. So let's say he wants to be within 5% of the true probability. So he wants to be within 5% of the true probability. He may in fact want to be closer than that. He may want to be within 2% of the true probability. But let's go with 5 for now. This means our E in this formula is 0.05 for 5%. And so we have N equals 1.96 squared times 0.25 divided by 0.05 squared. And if we do this arithmetic, we should end up with 384.16 and some more decimals there. But what we know is that we always round this value for sample size up, right? That's what we said in our last video. We were going to always round this up. So what this means is that if I want my probability to be within 5% of the true probability, I need to do at least 385 trials. I need to do at least 385 trials. So the 30 I have is certainly not good enough to give me a real estimate of this probability. I need to do at least 385. Now, we're also trying to estimate a mean. So remember our formula for the sample size to estimate a mean. The formula for the sample size necessary to estimate a mean was that 1.96 critical value times the standard deviation over our margin of error, and we're going to square that. Now, what do we want to use for E? How close do we think Sanjay wants to be? He's estimating his monthly salary. So let's say he wants his monthly salary to be, I don't know, within $1,000 of the true value. Now, he may in fact want to be closer to that. Personally, I know if my salary was $1,000 less than I was expecting a month, that would be a real hardship. So he may want to be closer than that, but for our purposes, we'll go ahead and say as long as he's within $1,000 of the true value, he'll be okay. The other piece of information we need is S. And S we get, this is why we did the preliminary sample. Right? We get this from our preliminary sample. We're going to use the standard deviation from our preliminary sample. So what I'm going to do is I'm going to go back to my Excel sheet. And what I need is I need the standard deviation of his salary. And so remember, under data and data analysis, we can get all of our descriptive statistics. So in data analysis, we want to choose our descriptive statistics. Hit OK, and then we're going to get our pop-up window that asks where our data is. Now my input range is this salary, so I'm going to grab from salary on down. Grab all my trials there. My data is in a column. I did grab the label in the first row. I want this to go to the new worksheet ply, and I'm going to call this preliminary statistics, because these aren't the final statistics that I'm going to want to use to inform Sanjay's decision. These are just preliminary statistics. We have to check that summary statistics to get the value that we want. I'm going to click OK, and it's going to calculate my descriptive statistics and open up my new value. And you see I get, for this small sample that I have, right, my sample size 30 down here, I want this standard deviation, and the standard deviation of this sample is 16,228. Since this is money, I'll take 2 decimal places, so we'll say the standard deviation is $16,228.26. And so if we go back to our document camera, we can calculate this. So our sample size N should be equal to 1.96 times 16,228.26 divided by 1,000, and then we're going to square that. And when I do out that arithmetic, I get 1,011.71 and some more decimal points, but remember, we always round this up to 1,012. And so the sample size we need to estimate our mean within $1,000 is 1,012. Now remember, our preliminary sample was made from randomly generated numbers, which means that your value for S may have been very different than mine. And if your value for S was very different than mine, you may land at a different sample size N. That's okay. That is okay. It's based on what you get. And so we're going to take this, since these are the 2 values that I got, 385 and 1,012. I'm going to choose the larger of those 2, which is 1,012. And I want to do 1,012 trials. 1,012 trials. And so I need to go back into Excel, right? I'm going to go back to my sheet 1, which is where my data was, and I need to increase this to 1,012 trials. So I need to grab a few values there in that first column for the number of trials because I want to continue that pattern, and I'm gonna drag it on down just to help me know where to stop. Since I started at 10, I want to stop when I get to row 1021, so I'm going to grab that and drag down. And it's going to be painful, but we can get this many trials in there. And so we keep dragging this down until we get to our 1,012 trials. And I can see that I'm getting closer. All right. Feels like I'm almost there. Now there's nothing wrong with doing more. I just don't want to do any more work than I absolutely have to do. So I'm going to back this up. And so there's 1,012 trials. 1,012 trials. Now we need to copy the rest of our data down to that many trials as well. Now, to copy down our other formulas to the cell, there is a shortcut to do that. So what we want to make note of is the last cell we want to copy that to. So in my case, the bottom cell here is 1,021. And so I'm going to go back towards the top where my other data is. Scroll back up. And I'm actually going to go to the bottom of the data that I have entered down here. And what I want to do is click the cell that has the formula in it that I want to copy. So I'm going to click that last cell in the column that has the formula. I want to copy down that column. Now I want that formula not to stop at this cell B39, but I want it to go from B39 all the way down, and my last cell was 1,021. So I want it to go down to 1,021. So while I'm clicked on that bottom cell that has the formula, I'm going to go up here on the left hand. This is what's called the name box in Excel. So on the left hand side, I see where it says B39 because that's where I am. I'm going to click in there, and I'm going to click again to get my cursor. And I want this formula to go from B39 down to B1021, 1021. So I have B39 colon B1021. It's going to copy the formula all the way down to cell 1021. I hit enter, and you see how it highlights all the cells where I want to put that. So I hit enter. Now to get it to actually paste the formula there, I want to press Control D. Control D, and it'll paste the formula in all those cells. And it's much faster than grabbing it and dragging it through thousands of cells. Now I need to do that for each of these columns, so I'm just going to keep moving across. And so the formula I have in cell D39, I need it to go down to cell D1021. So I'm going to click on D39. I'm going to go back up to my name box, and I'm going to put colon D1021. And then I hit enter and Control D, and it copies that formula down for me. And I move on to my next column, which is F39. So I click on F39, and then I click in my name box, and it's colon F. I want that to go down to F1021. 1021, I hit enter, and then Control D, and it copies it all the way down there. And I move over to H39, and I do the same thing. So H39 colon H1021, enter, Control D. I39, so I39 colon I1021, enter, Control D. And finally, J39 colon J1021, enter, Control D. And now I've copied my formulas down to all the trials of my simulation, all the way down there. All right, so now that we've done enough trials, we want to go ahead and analyze this data. And this is where I said, before you analyze the data, we need to fix the data values. Notice every time we copied something, we pasted it, we changed all the values in our simulation changed. We want to stop that from happening. And so what I'm going to do again, before you fix the data values, save your file. Before you fix the data values, save your files, because this is where all your formulas live. And once we fix the data values, you won't have any of these formulas. And so if you want to look back and reference it, or you want to show how you calculated something, or you find a mistake and you want to fix it, you can't do that once you've set your data values. So we need to save this file. So I'm going to go to File and Save As. And this is no longer my preliminary sample, so I will save it as Gentle Lentil Unfixed Values. Right? So I know these are my unfixed values. So I'm going to save that file. Right, again, I'm going to ask for this when you do assignments, so you want to make sure you have this. So save that file before we move on. And then what we want to do is fix the values. There are several ways you can do this, but the easiest is to copy and paste. So when we want to copy a large range of cells, we could grab, what I want to copy are just these cells that have the data in them, right? All of the cells with the data values in them. I don't need to copy these titles. I just want to start with my very first trial, and what I'm going to do is copy all of these. And I actually don't even need the trial number. I can start with where my randomly distributed or my random numbers are. And so I'm going to grab that very first corner of the meal. Now I could click that and drag it down here. There's a couple of different ways to select large numbers of cells, but since we have such a large number of cells to select, I'm going to say that the easiest way is to click up here in the upper left corner of the cell that you want, of the range that you want. Now, my data ends in column J, and I know from all of the other copying and pasting that we just did that my last row of data is 1021. So what I'm going to do is click here in B10, which is my upper left corner of what I want to copy, and I'm going to go up to that name box again, and I'm going to say I want to go from B10 colon, and what I want is to put in the reference for the bottom right box, which in my case will be column J and row 1021, because the lowest row is 1021. So I'm going to go from B10 to J 1021, just like we did before for one row, but this is going to give us a rectangle of data. Then I hit enter, and you see where it highlights all of that stuff, right? It's selected that whole range. Now what I want to do is copy this information. So I'm going to click over here, I'm going to click copy. And then what I want to do is actually paste it right over top of where it is. So I copied it, and now I want to paste it right over top of where it is. So I'm going to right click, and you see all these options for paste. You have all these different options for paste. So we want to be very careful here, and if you're using your menu to pick paste, make sure you go to paste options, not because if we just straight up paste, it's just going to paste back what we have before. We want to paste only the values. What that's going to do is copy the values that are in our cells at this moment, and it's going to paste only those values, no formulas. And so I'm going to click on this paste values, right? And now you see if I click around these cells, all that's in there are the numbers. It took the numbers that were there at that last rotation and it fixed them. So this is what I mean by you need to save your file before you do this, because all of my formulas are gone. All that I'm left with is the values. Now this is good from the perspective that if I want to analyze this data, I need these values to stop moving around. And so this is the file that I want to analyze. So just so I don't accidentally save over top of those unfixed values I saved, I'm going to take a moment and I'm going to save my fixed values. Right? So I'm going to save my Gentle Lentil, and I'll maybe call it Gentle Lentil Complete, because this is after I fixed my values. This way I know I have my unfixed one and I have this one that has the values fixed. And this is the data that I want to analyze. And so there's a couple of different things that we want to do here. One, he was very interested in his mean salary or his expected salary. So I want to create the descriptive statistics for this salary column. So I'm going to go to data analysis and descriptive statistics. And I want to be careful because this has my preliminary data range. But remember, now my data goes all the way down to 1021. Now I can grab and drag down there if I don't remember. But I remember that my column went all the way down to 1021. So my input range is from H9, where my title is, down to H1021. My data is in a column. I did put the labels in the first row. I want to name my worksheet ply. Maybe I'll just call it descriptive statistics, or maybe I'll call it salary statistics. Okay. I need to check summary statistics off to make sure I get those values, and I'm going to actually check off this confidence level for the mean to be 95%, and that's going to help give me a confidence interval estimate for my mean rather than just giving me the sample mean. So I click OK, and it's going to calculate that. It gives me my tab with my salary information here. All right, and we can see from this that the predicted mean salary is $42,847.96 per month. Right? This expected salary is way higher than the $5,000 that he was looking for. Now, I'm going to answer my questions here. Remember, his first question was, what is the expected monthly salary, right? And so in this case, this tells us this $42,847.96. Right? We can actually be a little more specific here. I checked off that confidence level button. And so you see down here where you have this confidence level, 95%. What this is doing is giving you a confidence interval estimate. It's giving us a confidence interval estimate. And so what this does is, rather than saying I expect his salary to be this $42,847 each month, we say we expect his salary to be between this lower bound and this upper bound. This is what we call the margin of error. So when you hear people do studies and they give you the margin of error, this is the value that they're referring to. This is the distance between our sample mean and where we expect the true mean to be. And so what this means is that if I take my sample mean that I have stored in B3, so I'll say equals B3, and I subtract that margin of error that's in B16, that's the lowest that I expect his monthly salary to be. To get the maximum, I take my sample mean, which is in B3, and I add that margin of error from B16. And what we're saying here is that with this 95% confidence level, we expect the monthly salary to be between $41,688 and $44,007. So his confidence interval estimate for his average monthly salary is between this $41,688 and say 49 cents and $44,007.44. Now remember, if you're working this along with me, your numbers might not be precisely the same as mine because this is based on randomly generated numbers. If we've done enough trials, we should be in the same area, but they will not be precisely the same. But this is our estimate on where we expect his monthly salary to be. The other thing he asked about was the shape of his monthly salary. And so for the shape of his monthly salary, I'm going to construct a histogram of his salary. And so again, I go to data analysis and I choose histogram. And my input range, I can see it here. I'm going to start at H9. And remember, we went down to H1021 was where our values ended. Now, I didn't calculate my bins yet, so I'm going to go ahead and cancel out of this so that I can put some bins in here first. So let's do a couple of calculations to figure out our bins. Remember, our bins would take the, we said the number of bins. We wanted, I'm going to put one more space in here. There we go. I like it a little further over. So the number of bins we wanted would be equal to the square root of the number of things in our sample size. And our sample size was 1012, so it's going to be equal to the square root of 1012. So this came up with 31 or 32 bins. Now, good practice is to always have between 5 and 20 bins. So despite the fact that this came out with 31 bins, I'm going to use 20 bins because we really shouldn't ever go above 20 bins and we shouldn't go below 5 bins. So I'm going to use 20 bins, and then I need to find out how wide each of those bins would be. So I need to find my maximum value for the salary and my minimum value for the salary. And so remember, we take the maximum of that column, and my numbers are between H10 and H1021. And I want to find the maximum in there, and I want to find the minimum between H10 and H1021, right? And so for our width, we said we would take the maximum, which I have in M12, minus the minimum I have in M13, divided by the number of classes, which I want to be 20. So our class width is this 7,071.22. Now my lowest value is negative 34,433. So what I'm going to do is maybe make my lowest bin start at negative 35,000. So that will be below the negative 34. Make sure I capture that guy. And then I'm going to count up by 8,000s. I'm just going to round this so that I'm not working with such an awkward number. Maybe I want to count up by 7,500s, but I'm going to go with 8,000s. And so next I would have, what, negative 27,000, negative 19,000, negative 11,000, negative 3,000, right, 5,000, 13,000, 21,000, 29,000. Right, my maximum is 106,000, so I need to keep going until I get there. All right, so now I've gone higher than my maximum. So I started below my minimum, I went higher than my maximum. All right, and so now I want to put in my histogram. So the data I have, my input range goes from H9 to H1021. Right, my bin range is here. I did include the labels in those columns. I'm going to put this in a new worksheet. This will be my salary histogram. I need to make sure I click chart output, otherwise it won't actually make a picture for me. I hit OK. And there's my histogram. I'm going to stretch it out to make it a little bit bigger. It's actually a nice histogram. This is relatively normally distributed. See that? Relatively normally distributed. A little wonky here, but overall this is vaguely normal, right? This means that his mean is a good measure of center, so he can be fairly confident in this expectation. Most of his data values do lie right around here. Our actual bin values kind of represent that as well. You see he's got very few months where he loses money. He's got a few times in that 1,000 where he loses money, but most of the time he's making over that 5,000 that he wants. So we see this is a good shape. So his shape is vaguely normal. So if I go back to my salary statistics and I say, what is the shape of the salary distribution? I can say approximately normal, which is a good, when I'm gauging the reliability of that estimate, that's a good sign. The other thing it asks for is what is the standard deviation of the salary. And our standard deviation is right over here, right? It's this 18,796. Want to be real precise, we can put in our 80 cents, right? This is a high standard deviation. Even considering that our expected monthly salary is $42,000, 18,000 is a high standard deviation. That's almost half of our mean. So this is a high standard deviation. Now, looking at my shape, this is likely caused by these guys over here, right? We have particularly this one straggler, this outlier over here. You see him kind of pulling everything down. Some very high values here. Standard deviation tends to be a measure of risk. The higher standard deviation, the more risky the prospect. So a standard deviation of $18,000 isn't really great. It means, what it tells me is that sometimes we're going to be way off that expected value. Way off that expected value. Now that said, Sanjay was after $5,000 a month, and the expectation we're giving him is roughly $43,000 a month. So even if he is off by $19,000, he's still well above where he wants to be. What he needs to know about this is that he cannot count on $43,000 per month, right? He needs to know that there's going to be times where this is going to be way off from that. However, given that this is so much higher than what his desire was, this still seems like a pretty good prospect. The last things we wanted to ask, or we wanted to look at, were what are the probability his salary is over $5,000, and then what is the probability his salary is under $3,500. Right? So if we go back to our salary information that we had over here, the way I'm going to calculate that is, notice I put a 1 in every time his salary went over $5,000. What that means is that, and a 0 when it didn't. So if I add up all the values in this column from I-10 down to the bottom, which was I-21, right, from I-10 down to I-21, that will tell me how many times his salary went over 5,000. And so I'm going to give myself a little bit of space in here. Give myself a little bit of space in here to work. And I'm going to write, when is his salary? His times the salary is over 5,000. And then I'm also going to do the times his salary is under 3,500. And so for the salary over 5,000, remember, I'm going to add up all these numbers from I-10 down to I-1021. That's going to tell me how many ones there are, so how many times this happened. So I'm going to put equals, and I'm going to use the sum function in Excel. So I'm going to sum from I-10, and mine ended in 1021. So to I-1021, I hit enter. So 980 times, there was a 1 in there. 989 times it went over 5,000. Similarly, I'm going to sum J10 through J1021, and that's going to tell me how many times it went under 3,500. So 989 times it was over 5,000, and 20 times it was under 3,500. So if I go back to my statistics where I'm writing my answers, remember, probability is is approximately equal to the relative frequency of something. So the probability his salary is over $5,000 is approximately equal to the relative frequency of when it went over $5,000, which in this case was that 989 times divided by how many trials we did. And we did 1,012 trials. So the probability his salary is over 5,000 is 97.7%. 97.7%. It's almost certain, right? It's pretty close to certain. The probability it's under 3,500, well, that happened 20 times out of the 1,012 times. And so the probability that it is under 3,500 it would be 1.976, so roughly 2% chance that it's under 3,500. So the probability he gets what he wants is 97.7%. The probability he would need his aunt's help is 2%. And so when he's making his decisions, I would take a look at these. And so once we have all of this, right, we've simulated his salary for a reasonable number of trials. We've gotten our summary statistics. We've answered the questions that he posed precisely. In the end, what we want to be able to do is make a recommendation. Should he take that consulting job, or should he open his restaurant? And if he opens his restaurant, should he partner with his aunt or not? I would take a look at this, and I would say, based on this expected monthly salary, even with such a high standard deviation, it is approximately normally distributed. I would feel pretty confident telling him opening this restaurant was a good idea. I think he's going to get what he wants and what he needs from opening his restaurant. His expected monthly salary is well above what he desires, even taking into consideration that standard deviation. And this normal distribution gives a good gauge of confidence in this estimate. Also, the probability that his salary is over the $5,000 that he wants is really high. So there's a really good chance with this restaurant he's going to earn that $5,000 a month that he wants. In fact, I would say based on these numbers, there's a good chance he's going to earn well more than what he wanted. Well more than what he wanted, and even more than he might make with that consulting job. This has a good probability of being very profitable. Now remember, this isn't for certain. This is based on simulated data, and this is probabilities. But my recommendation would be to open the restaurant. Based on this simulation, my recommendation would be that he go ahead and open that restaurant. Now he needs to decide whether to partner with his aunt or not. And there were months when he was under that $3,500. There were months when he was under the $5,000 that he wanted. In fact, there were months, if we look at that histogram, where he was losing money, and not just losing a little bit of money, but losing $27,000, losing $3,000, losing $11,000. There were some pretty bad months in there, but they were very few compared to the good months. And in fact, very few compared to a lot of really good months. The chance that he needs her help is 2%. Now, when he needs it, he'd need it really badly. However, if we remember from your reading the caveat of her condition, she said she would help out in exchange for 90% of all monthly earnings in excess of $9,000. Based on this histogram, his earnings, a lot of his earnings are in excess of $9,000. She is taking 90% of all that in excess of $9,000. She's really making out on that deal if things fall out this way. I would say that what Sanjay should do, rather than partner with his aunt, who will take such a huge chunk of his profits in the good months, is to save his money in the good months. Don't say, I made $40,000 this month and go out and spend $40,000 this month, but live within his means and save $10,000, save $20,000 for that month when he loses $11,000, pops up. Again, these are not exact values. We are not saying in his first month of business he's going to make $36,000 and in his second month he's going to make $29,000. This is simulated data over a long period of time. We are looking with simulations, we are only looking at averages and shapes. We expect in the long run his earnings to average out this way. And based on that, I would recommend that he open his business and that he not partner with his aunt, but that he save his excess earnings for months when things aren't as profitable, to fill out his salary himself when things are not going well. So with our simulated data, we want to take, or with our simulation model, we want to take all of the information that we have, we want to simulate our data set, and once we have that simulated data set, we want to get our summary statistics, and we want to use that data to answer all of the questions that we've posed. Based on those answers, then we can make our recommendations like we have for Sanjay. And so we use that simulated data to make these recommendations and make decisions to help inform our decisions in our real world problems. The big things we want to keep in mind when we're looking at simulation models is that we are not predicting certain outcomes for certain months. We are predicting long-term averages. And so it's important that what we're focused on are not the individual outcomes of each trial, but these summary statistics, these descriptive statistics from a whole run of trials. And we want to make sure that we've done enough trials to be reasonable. So now that we have all of our answers here, I'm going to make sure that once again I save this in my complete file. I don't need to save a new copy because I haven't done anything, but I'm going to save that in my complete file. So remember, as you work these problems, to save before you fix your data values and then save after you fix your data values. You want to make your recommendations, again, not based on the individual data values that we see in our trials, but on our summary statistics and on the shape of our data. We answer our questions and make our recommendations.